Okay, so here's some answers to the functions with oblique or slant asymptotes problems. So the first problem is this one, y equals x squared minus x minus 2 all over x minus 3. So the first thing we want to do is figure out, we want to divide this out so we can figure out what type of asymptote this is. If you look at the top, it's a second power equation on the top and a first power equation on the bottom. So that's going to tell you that you'll have a linear equation when you divide it out. So you'll have a linear equation as the oblique asymptote. So we'll go ahead and set this up as a division problem, like that, and divide. So if we divide out, we get x squared minus 3x. That ends up being 2x minus 2. Let's go ahead and add 1 here. Not 1. 2. There we go. Okay, so that's 2x minus 6, and we subtract and we get a 4 left over. So the equation that we're looking at graphing is x plus 2. So x plus 2 plus 4 over x minus 3. So that's equivalent to what we started with, and that's what we can do to figure out how we're going to graph it. So let's call that f of x. Okay, now, there's going to be an asymptote at x minus 3 because that's where that blows up on you. So we're probably looking at something like this. We have at x equals 3, there's an asymptote. Okay? We know the oblique asymptote is x plus 2, so that's going to look like this. And that's going to cross at 2 here, and then negative 2 there, because x plus 2 is a slope equal to 1. Okay? So really, we only have a couple of choices. The function can go like this, and then come like that, or it can do this, and the other side can look like that. So now we'll figure out which one's which. So now we can take the derivative. So f prime of x is equal to 1 plus, okay, let's see, that's, I'll go ahead and I'll do the song. So low d high minus high d low over low low. I have hecklers in the background saying, sing it. Low d high minus high d low over low low. There. I got applause. 4 over x minus 3 squared like that. So there's the derivative. When does this equal 0? That's going to flush out for us the critical values. Oh, it's a negative there. Okay. So that's going to end up being 0 when 1 equals 4 over x minus 3 squared. So x minus 3 squared is equal to 4, and that means x minus 3 is equal to plus or minus 2. And so our critical values then are going to be x equals 3 plus or minus 2. So at 1 and at 5. And that looks like it's going to make sense. At 1, there's 1. Our value of our function is 1 plus 2 is 3. Let's see, I have to kind of do this off on the side here. 3 plus 4 over negative 2. So 3 minus 2 is equal to 1. So 1, 1 is going to be one of the critical values. And the other one's going to be over here when x is equal to 5. The critical value will be up here at 5, 9. So this is 1, 1, like that. Okay, and that's just going to mean that the function's going to have to do this kind of thing and go down, and it's going to have to do something similar like that, and then approach the oblique asymptote. Okay, and we know it doesn't do anything else because let's suppose this function actually came up across the asymptote and went down like that. If that were the case, we'd have another critical value here where that hump was, and we would also have a situation where this little extra piece added on would have to be 0, and it can't be 0 because the numerator is always equal to 4. So there is problem 1 of that worksheet.